Hello everyone, today we're going to take a look at Express and we'll be looking at it in the context of an already finished application written in script together with Docker and with everything else included. But before we start, if you want to get advanced information, the code from this video, help, consultations or advanced materials, all of that is available on my Telegram channel. Just go to the description and the very first link will be to my Telegram channel. Go ahead, subscribe, there's a lot of interesting and genuinely useful stuff there. Let's start with what Express actually is. Express is a micro framework. In fact, I've already had a video about backend on Node.js. There, we quickly made our own Express-like library. But if we're talking specifically about Express, then Express is a micro framework, and there are quite a lot of them. There's Express, Koa, and Fastify. Well, Fastify is a bit bigger. Fastify is actually a larger ecosystem, so it should be discussed a bit separately from this. But if we're talking about Express, well, it's a micro framework. Let's start by looking at what we have in our project. We have a script, and that's why we have this .json file. We generated our config.json, and then we moved on. Then, using npm init, we generated our project. Now we have a package, JSON file. In order for everything to work, we need a few libraries. Let's start with the fact that we need a body parser. Why do we need it? So that we can send our body in a post request and parse it accordingly. Well, it can also handle some other formats, but that's not the point. The important thing to understand is that without it, we basically can't handle either post or path requests because we can't pass the request body. Next, our dependency is Express. Obviously, we can't work without Express. And then PG is for working with the Postgres database. After that, we have Sequelize. We need Sequelize specifically so we can work with the ORM. Well, in general, Sequelize is the ORM for our database. There's TypeORM, Sequelize, Prisma, and many others. I actually talk about all of this on my Telegram channel, but that's not the point. If we talk about just Sequelize, it's quite old, but still pretty decent. It's a good solution for working with the database as an ORM. Why do we need an ORM? We need an ORM so that we don't have to work directly with raw SQL, because when working with raw SQL, there's always a risk that we might forget to escape parentheses or something similar, which could open up our code to SQL injection vulnerabilities, and that's definitely not desirable. And just like with Sequelize, we also have a dependency on TypeScript. Why do we need this? So that we can work with TS. Because as we can see, our project uses TypeScript. The project itself is actually quite small. There isn't much folder structure here. If we speak a bit more abstractly, let's imagine that this is a kind of microservice that after that, as dev dependencies, we have types for Express, types for Node, then Node daemon, then TS node specifically for running our project. And then we have TypeScript itself, which is needed to run and generally work with TypeScript. And we've reviewed the package JSON. Let's move on to index.ts. In the index.ts file, what do we need for our application to work? Naturally, we first import Express, then we import body parser, and then we import some kind of database. We'll go over that. We'll also look at the config and some controller as well. To start, in order to launch our application, we need to create an instance of our app. So we write Express. Basically, we call it. Strictly speaking, it's not really an instance. We just call Express and get this kind of interface here that we can work with. At this point, we can already run our application, set up some routes, assign some middleware, and so on. Then we have the port here, which we set to either 3000 or whatever we're working with. And after that, we have middle awards. What is middleware? Middleware is an intermediate value. So, for example, let's say we have a client. Here's our client. They make some request, and we have a server. Middleware, roughly speaking, gets embedded into this request. And right here, it can intercept the request. If we have several middleware, they line up in a queue, processing our request one after another. That's putting it simply. In the context of our application, the body parser, roughly speaking, takes the body that we send in our request. And in the middleware, we modify it. That is, we format it as JSON so that we can work with ITANs. Then we pass it on to our server, meaning to our controller. Before you continue watching, I highly recommend that you check the description, go to my Telegram channel and subscribe because the newest, most up-to-date information always comes out there first. There I run polls to decide which technology we'll review next. There will also be contests for free consultations and so on. There will be lots of new perks, so go to my Telegram channel and subscribe. And after that, here we have a body parser represented by these two middlewares in order to get JSON so that we can extract this data. After that, we assign our route. We've used, besides being able to assign our middleware, we can also assign a route. And use todos means that for the todos URL, we will be working with the current router. And by working with the current router, we will redirect to the routes that are inside it. We explore, and here is the function to start the server. What do we need when starting the server? That's the creation of the database. Well, not the creation of the database, it's when we connect to the database. Naturally, there's the matter of sync here. What is sync? Roughly speaking, we synchronize in such a way that any changes in the database are detected. These changes are immediately applied to our actual database in Postgres, which isn't ideal because what we really need are migrations. So if you want to expand the application further, the first thing you should add is migrations. What are migrations? Migrations are, roughly speaking, a snapshot of our changes in the database that we can apply and roll back, because when we make any changes, we don't have a history, and we have no idea what might be happening with our database. Having the history in front of us gives us the ability to either roll back or see what the problem is, and so on and so forth. That's why it's better to play around like this only in applications that are either for yourself or not very large, but in production it's migrations only, because you can't go anywhere without migrations. After that, we start our server using app listen. We specify the port, and here we write that our server has started on this port. And then we call our function to actually start it. This function is the initializer function, which basically means we're launching our application. To do this, we need to connect to the database and we need to start our server. Okay, we've set up the middleware, everything's great. After that, we need to work with the route. That's self-explanatory. So we call our todo router and get the default. Of course, to keep it simple, you could just import it directly. I just did it a bit in a hacky way, but still, let's move on to the controller. Let's go into the todo controller. What do we have here? In order to split our routers into different files, so for example, we had a todo controller, a user controller, and other controllers, we need to use a router in Express. The router is needed so that we can create routers in different parts of our application and then import them into our main file. Well, for example, following the same principle, we created our router and then defined the endpoints. We define the endpoints way, can set up the router. So we can set up the router here, and here we can configure it in a more advanced way. Well, maybe not exactly advanced, but we can specify more configurations regarding how our route will be handled. Simply put, and nicely, for each of our methods in the router, there is a specific method just like this. We have get, post, put, delete, and patch. All of these can be used. In short, we have get for retrieving all records, get for retrieving a single record, then post for submitting our data, and then put for updating our data. Well, there should be a divide. Let's go ahead and add our delete right now. Router, divides. There we go, done. We're getting suggestions, that's great. We've added everything. Now we also have a router for delete. Actually, we also have patch, but since we're going to update everything at once, we can basically skip the whole patch thing. So while we're updating everything, we need to pass all our data in our DTO, after which our changes will be applied. Actually, patch is generally used to update our data in a more traditional way. That is, for example, just one of our fields. Let's first look at retrieving all records. It's very simple here, but there is a division into services. Naturally, you shouldn't write all the logic in controllers, because a controller is meant to receive a request, maybe process it somehow, make some changes, but nothing more. You shouldn't write any database logic there. It's better to create some kind of service for that. Here we have a todo service which has a get all method. Let's go there, let's open the service, the todo service. It doesn't look particularly elegant in the context of export default, and the functions look like this. Nevertheless, you can still organize it this way. Some people use a class, some create repositories, everyone does it differently, but it's done this way for simplicity and clarity so that it looks straightforward and easy to understand right away. Let's start with the fact that here we have our get all, we access our todo, and get find all, and we'll come back to the entity a bit later. But for the sake of simplicity, let's imagine for now that todo is our model that exists in our database. That is, we have some kind of model in the database, a todo table, which we will be modifying, updating, adding to, retrieving from, and so on. And in the current situation, we are retrieving everything. We have an ORM that gives us the ability to perform a find all. The ORM not only provides some safety in certain areas, but it also simplifies interaction with the database itself, because some commands like create, update, destroy, find all, and so on are already handled for us. With find all, we retrieve everything. With find one, we can get a specific record, but in our case, we need to use where to fetch it by a certain key. We specify the key here, and we get the ID. After that, we have creation. Here, we use create and pass in the fields that we want to provide. It's important to mention that in our todo, we have a title, description, and an ID. In addition to that, I think we also have published and I believe some dates. We'll look at that in the entity. But briefly, I think that's about it. But there should be something else as well. After that, we have an update. In the update, we pass the fields that we want to change, and then we have a key by which we'll actually make our changes. That is, we find our record by this key and update our title and description. After that, we perform a destroy operation using our ID. Actually, I think we have more fields than just title and description. I believe we do have several fields. Yes, here we have title, description, and publish. So ideally, here we should use patch instead of put. But again, everyone does it differently. Patch is for some kind of partial modification of certain selected fields, but that's just it. Usually, in real-world applications, everyone does it their own way. So you can use patch or put. It all depends on what you and your team have agreed upon. But put is for all changes, patch is for something specific. Okay, we've covered that. Now we have our service. We'll get back to the entity. I kind of jumped ahead there, but we'll return to it in a moment. We have a service that implements the logic for working with our entity. That's fine. But here we see that there's some DTO. DTO is a date transfer option. Naturally, when we're working with TypeScript, we can't just use our entity as the type that's being passed in. In other words, we can't just do something like that. Why can't we do something like that? Because in this situation, we're breaking one of the principles. Our todo should remain internal, and we shouldn't reference it directly from our service. Instead, we should be passing data between our layers. Let's go back to the onion architecture, or hexagonal architecture, some people call it. The onion or hexagonal architecture assumes that we have a unidirectional flow of data. In our current situation, we're using the DTO from our service. Okay, well, the todo from our service, but in some cases, we might pass certain types outside of our service, in some layers near the controller. So here, this is what we'll be passing. Naturally, when working in this kind of setup, when we're writing here, we won't be able to specify something like a todo as a type here. It just won't work, because that would break this principle. That's why we have a DTO, which defines which fields will be passing between layers. This is, roughly speaking, a sort of contract that specifies we have a service layer, we have a controller layer, and according to the total DTO contract, we'll be passing this data. That's the short version. And a DTO is a transfer object. It looks absolutely straightforward. It's just an interface where we have ID, title, description, something like that. Actually, there are separate libraries for this. In Nest, we have a validator class that works with DTOs in a more convenient way. In fact, here we have a second point that could be improved, which is validation, because in our current setup, we don't have any validation. We can pass, for example, just a title or something like title1 and so on. That's why we have the option to use TS REST. We have such a library, and I also covered it on the Telegram channel. We have the opportunity to work with Joy. Joy is exactly what we need to define this validation and so on. And as a second point, besides what I mentioned about migrations, validation could also be improved here. Because validation needs to be implemented. Without validation, things will get really bad and painful at some point, since this application is just for demonstration. But in a production environment, you absolutely need some kind of input validation. In Vit's, much easier to do because it's built in, but in Express, you have to connect some third-party solution. We've covered the detail. The detail is needed so that we can pass data between our layers. In other words, here we'll be receiving both todo and todo detail. Okay, good. Now let's go back to the entity. But before that, let's get into the story with our DB. Let's talk about the DB and take a look at it. In order to start our application, right here, we refer to our DB. At first, we didn't understand. Now, let's go ahead and take a look. We can see that here, we set up our application, specify the initialization, and define which database will be working with username, password, models. And we have a connect function, after which we need to establish a connection. Let's look at sequelize, authenticate. If authentication is successful, we get a message saying everything is great. If there are any issues, errors are thrown. Great, that's good. In our current setup, we've connected to our database, but that's it, we're connected, and nothing else is really happening. So let's go back to, and in our current start server, we call sync in order to synchronize our current application, any possible additions or changes with our database. That means every time we make any changes, those changes will be applied to our database and we'll be working with that. That's cool. But let's take a closer look at how we connect, because we can see that DB user, and DB password are being added from the config. Let's go to the config and see what we have there. And in the config, we're simply passing our .env config so that we can get our variables from .env. And here we're already getting the port. Actually, this isn't done quite correctly because here we're adding some other separate variable. What's better not to do here? We can do it absolutely like this and just change things here and here. So if our port isn't available, we'll just pass our port from the config here. So in the config, we take our variables from the process, which are stored in the env, and naturally they have to be stored somewhere. Here in the env, we have our variables that we pass in. Ideally, our suggestion is to fully package the application in Docker. The current implementation just packages Postgres in Docker. So our database is started from Docker. From Docker Compose, I wrote a Docker Compose file to make things simpler. And in our application, we simply connect to it, and we connect through dbts. Here we connected in our index.ts, synchronized, and the process worked. And after that, our totals are processed and so on. Let's move on. In the entity folder, we have a model. In general, sequelize TypeScript gives us the ability to define our models more conveniently because we write them in the form of classes with decorators and so on. Actually, there are decorators in TypeORM as well. This also allows us to work conveniently. Actually, originally there were no decorators in Sequelize. There was only the option to describe everything in an object. So we would write wait. I'm pressing the wrong thing here. Okay. In the object, we would define, for example, to do define and so on. And here we specify, say, the name. We write it out in this kind of format, something like that. But this isn't really correct. It's not very convenient and it's hard to read. With a class, though, it looks much more convenient and is organized in a simpler way. So what's happening here? In the current implementation, in order to work with our model, we have to specify the table. Here we write the table name, we specify todo to indicate which table we'll have in the database. After that, we have IDs or columns. To specify a column, we use our column decorator. To specify any additional parameters, we define them in the object. What type is it? Integer. Is this a primary column? Is it auto-incremented? It is, what will the field be called? ID. After that, the type is the same. String field title, type string, field description, boolean field publish, and we specify the types. That's the principle it works on. After that, we can actually first we need to import our table into model so that our table is created in the database, and then in the service we can perform similar operations. Okay. In Docker Compose, we can see that our database is starting up. In package.json, we can see that to start we use nodaemon index.ts. Let's go ahead and start our application and see how it all looks. All right, I think I've cleared the ports now and remove the containers that were using the same port. Let's press it. Here we can see that create our database has started up. Let's try to run our application. After that, our application starts. We can see that some kind of error has appeared. Well, of course, we changed things here. We changed something here, but didn't update our port to the correct one. Actually, before every launch, well, ideally you should also connect a linter, maybe some kind of formatter, so that we have hints, assistance, and so on. This is to help style the code. So what can be improved? The first thing is to improve the migrations. The second is to use test or joy for validation. After that, you can also connect ESLint, a formatter, and so on. You can find this code in my Telegram channel. There you can access it, pull it, get it, and add some features. In other words, you can practice with it. Let's get started. We see that something has started up. Now we can go to the total service. Let's open Postman and see how things are working. Let's try to do a GET request and retrieve everything. We see that we're already getting some posts because I added some posts. Let's try to get just a single post. We got one post. After that, let's do a post and add something with a request. We send it and we see that something has been added. After that, let's do a PAT request. Here we pass in, say, the number 3, and let's say hello from Todo3. We send hello, hit send, and we see that we get a 1, which means everything is okay. In general, we also need to style the responses in the correct format so that we have some kind of object for the responses so that everything is in a unified style and the front-end developer understands. Otherwise, it's not really clear what kind of response this is at all. So another way we can improve things is by adding a well. It's not quite right to call it styling, but rather a sample structure of the object that will be returned in the server's response. After which, well, we have a way. Actually, we shouldn't have pat here. It should be patchy. Change it to patch. Let's try changing it to patch. Oops, right. I added a router here, so the router handles it. And let's go through here with delete. Let's make it patch there. We're doing patch, doing it. We see that, well, overall, it's the same. After that, let's do a delete. Let's make some kind of delete. Well, let's fetch everything so we have the opportunity to take a look. We see that we have number 3 hello from Todo3 hello, and let's delete it as the final step. Let's delete our 3 divides. We see that it's 1, seems like everything is okay. Let's go, get, check. So oops, let's go, check. And we see that we have 1 and 2. That's basically it. We have reviewed our Express app in the format of a ready-made application with TypeScript, Sequelize, and so on and so forth. Everything is explained in more detail and broken down further in my Telegram channel. You can go there using the very first link in the description there. You'll find the Telegram, cheat sheets, and so on. So if you found this interesting or useful, subscribe, leave a like, and let's stay in touch.